Welcome to the Optimum CAD solution. I'm Pankaj Ratnabarki. Once again, we'll start our free online course that is Plastic Product Design and Advanced CATIA. Today, we are moving towards our next tutorial, which is the casting component, that is the U connector for the lever assembly. Those are the design details. By taking the reference of all these views and dimensioning, we will convert this 2D into the 3D. So without wasting the time, we'll open the CATIA and we'll start for the designing. So here, where in the CATIA, we'll take a origin point and then we'll use the axis system. We'll hide the three default planes. So as we are using the axis system, so no requirement of the default planes. So we'll start from the sketching. So select the sketch. It may be a position sketch or it may be a standard sketch. So here we are into the sketcher workbench. So we'll observe the dimensions. So those are the different views where you can see the section view, where we will start from that section view and the remaining diameters and dimensions are mentioned on the top view. So we'll start to draw the section view. By using this section view, we'll create one cylindrical shape of that particular component, that central cylindrical shape. So we'll provide the dimensions according to the dimensions given in the drawing. So here you can see the bottom is 108. As we are using the symmetric, we require a symmetric for cylinder, that's why we'll add the radiuses over there. So next one, that is the side diameter. So here that is mentioned the second line of the diameter. So here it is, that is the 140. This height is of this total height is given from base, it is a 500 and minus 305. So tentatively it will be a 198, 195, right? So this thickness is given 38 mm. So we are referring that section view, and after then we'll use the shaft command. So this largest diameter is of radius 99. After then we have to enclose this, but there is a smaller step in that section. I will just show you. So once we provided the basic dimensions, which will freeze the exact area of your sketch, and then we'll complete the remaining dimensions and lines. So the basic sketch get completed, and according to the given dimensions we will provide. So this is given as a 190 mm. So if you observe in the sketch, you will see that one cylindrical part is there, that's why that diameter and 100 and 198 diameter is different. So whatever process we are doing, it is correct, so just follow it. And this total 178. So here the section, whatever the section view given, so it is completed, and we'll use the shaft command here. So we'll take a body, we'll use the shaft command, select the sketch and then the axis to be shaft. So here the central cylindrical shape get completed. Now we'll moving towards upper holes, that is the slots, circular slot which is provided. So that pad we need to create. So for the easiest way, we'll take a plane which is 610 divided by 2, as we are using the symmetric. So once that created, we'll use the mirror command. So as usual, we'll refer the dimensions, we'll enter into the sketch, take the circle here. So whatever the cylindrical diameter it is shown as 114. So it's 114 mm. Then that point from the bottom it is 500, which is already we saw. Let's pad it for 95 mm. And as usual we'll mirror it. So here it is properly got mirrored. So next, use the position sketch. So for easiest what we can say, easy to sketch and easy to manipulate, we are using the position sketch. Okay, so take the references and we will start for designing of the side shape of that particular lever. So this side shape we are creating, it is 235 mm radius. As usual we'll take the radius command here, 235. So what are the thickness given over there? So here is also one radius, so we'll draw firstly rough sketch, after then we'll got the final sketch here by adding addition of that particular radius. Oh, something messed over there. If it is not getting horizontal, we'll delete it and we'll re sketch it. So let's zoom it and take a line, and after then just close it. So still it is not a horizontal, make it as a horizontal first and after then use the trim command. Okay, so that thickness is given as a 25 mm. So here the radius is 205 already given. So we need to just join it. Now this same profile is symmetric over another side, so we'll use the symmetric command. So auto search, select all the sketch and mirror it. So here we need to take a pad, but from the profile which is given, this should be closed. So we will make some easiest, it will be close, and after then we'll do that 108 mm pocket over there. Okay, so we'll close the bottom's pocket firstly. Okay, that I just shown that pocket we will close. So here we'll move for the sketch command, sorry, pad. So it is the pad of 178. I think it's a it's both side 170, it's a radius, so we have to put 178 and we'll make a mirror. So here that side profile get clear. So now remaining pockets will continue, no issue. So this pocket we need to create. So here we'll take the reference of this circle, and from that circle, so circle it's have its own one pocket which is having the diameter of the 50 mm, and this side cutout we need to create so that this profile will created. So let's take one rectangle here. That rectangle again having the mirror to the both side. Let's give the dimensions. As usual, it is a 305 mm, which is already given on the drawing here. So select all the sketch and mirror it from the central axis. So remaining dimension, there should be a profile should be ISO constraint, but for just practice purpose we are doing this. So here the pocket command completed. Now let's moving towards bottom shape creation. So at the bottom side, as we discussed already, so we need to create that 108 diameter pocket again, and we'll take the reference of this for creating the side pockets. We'll moving towards the, so this pocket we need to create. So if you saw that the dimensions are not properly given, but the constraints are given in the or clearly shown in the drawing. So we have to take the reference of this profile. So this profile we need to take as a reference. So we will delete it as it is not required. So this age we need to take as a reference, and after then that triangular shape we need to create. Okay, so if you saw that pocket is exactly from the edge of 178, that is the diameter. Okay, so we will take one line, or we will take a edge reference. Okay, so a reference of this edge, then we'll draw one triangle here which is started from that edge. It is should be at the central, and this triangle we need to remove. So this pocket we need to create over the both side, although four sides of the this profile. So we'll create the pocket here, and after then we'll mirror it. So now only one portion, that is the central rib, is pending. Okay, so this pocket get created, we'll mirror it over both sides, and here we got a proper shape. So this radius we need to add, it is 178. Okay, so now the almost part is get completed, only that central rib is get pending. So here that rib we need to create. So let's say enter into the sketch for creation of that rib. So we'll take that there are the four ribs or four ribs for the strengthening purpose. So those are the 30-degree, having an angle of a 30 degree. So we'll create one sketch of the basic rib over there. So provide all the dimensions. So we need to coincide this with bottom face. So we need to delete these dimensions as usual, and we'll coincide this with bottom face. Okay, and again we need to decrease this dimension. We'll keep it to the 168. So here we'll use the pad command for that particular rib, 10 mm mirror extent. I think by mistakenly we have selected the middle plane. So instead of that, we need to select the inclined plane. So uh, we'll change the plane here, sketch definition. So we'll change the plane here. So this rib is uh, nearly from drawing it is around the four ribs over that particular component. So we'll use the angular spacing, so 30-degree angle which is already provided, and will hide unnecessary ribs. Oh, it's a 60 degree, yes. So we'll hide this. So we got a four equiangle ribs. So that supporting ribs which is exactly at the center side. So let's will create. So as if we created at the bottom side, then the top pocket we need to create. So we will create this new pad just below to the pad 3. So either you can create as create or a designing as like I'm designing, or if you created at the bottom side, then that central pocket you need to add. So we'll take the reference of uh, the pad 3. Here all dimensions are get completed. So we'll see how it is looking, but we need to we need to create that central pocket again. So instead of that, we'll re-edit the sketch. So it's a 25 mm. So that central, we need either we can pocket it or we can control that into the sketch. So we'll control that portion into the sketch by taking the reference of central pocket over there. So we need to split this sketch by taking the references. Yes, we can create that. So we'll mirror it and we'll erase unnecessary portion. So we'll give the dimensioning for making the constraint, ISO constraint for the sketch. We'll keep it as a 198. It's a 185. We will keep it as a 185 here. So here our sketch got updated, and now we need to just define our final body. So here the our sketch is almost get completed. Some slight pockets and one pad is remaining, so we'll complete it also. So mostly this is the basic the component. Basically this component got created. So now we need to add that these 6 to 8 holes. We will take a plane, we'll enter into the sketch, give the required dimensions, that is 20 mm of a diameter, and the center point is 280 diameter. It means 140 mm away from the center point. So let's select the pocket, select the sketch, and here that pocket command is get completed. And now we'll use the pattern command. Complete con, that's the 6, and here is the axis. So here the pocket is get completed. So the two key points or a key cylinder on that the circular surface that we need to create here. So such components are created in the casting. So manufacturing process is a casting. So normally we have to create one masterpiece, and after then we'll create the sand. If it is a sand casting, then we'll create that sand mold, and then the material is going to be poured in that mold. After then the pockets and that finishing operation will be created. So this is the manufacturing process for such components, and definitely this video will help you for creating or to make the CAD part design model practicing. So here this is the finished product. Today's video is get completed. Thank you for watching our YouTube channel. We'll try to share more and more technical knowledge related to the plastic product design and advanced CATIA. But before that, you have to subscribe, like and share our videos, and do not forget to hit the bell icon. Thank you guys.